Is your patch management fact or fiction? I'm Ralph Langner, and in this video I'll show you a couple of ways how to examine your patch status. The OT-based asset management system provides a wealth of information on the patch level of all of your Windows computers in your networks. You can see all the installed patches, the installation date, and you even get additional metadata just by clicking on the link that is automatically provided by OT-base. But what about the big picture? How many devices are severely out of patch? Which computers are patched better than others? And why? For example, do differences have to do with different operating system versions? All these questions relate to patch distribution, and we'll examine how they can be answered using the Python programming language. First, we put the raw configuration data from OT-base using the export JSON function in the device inventory. And all we need to do for that is just to click this button. Here is what the result looks like when we load it into an editor. So as you can see, it's a JSON file. And if we look at the structure of the data, which is basically according to our portable inventory data format, every single device entry starts with the device ID and some basic metadata on the hardware. And after that, we get the connections. In this case, it's just one network interface. And we get all the software products that are installed on this particular device. And as you can see, there are various software categories. So we see the applications, but we also see the patches. We see any components that are installed on that particular machine. And that list can certainly become very long depending on how many applications, components, patches, etc. are installed on a given machine. Let's do some Python. The first thing that we do is to import the JSON module because our export file is in the JSON format. And now we are loading that file into a Python object, and I'm using a snippet here in order to speed things up. So I've just opened that file and loaded into this new object that is called PID. If you look at the file structure, which you still see open on the left, it starts with a meta element that we're actually not interested in. We're only interested in the devices array or list that follows in the devices element. So what we do is we assign our PID variable to the devices element. The next thing that we do is that we declare an empty result list for our results. And we call that new variable the patch list. So what we want to do now is to go through the PID list, which contains all the devices with their software installations, and then move the patches only into the patch list. And the code that we need looks like this. And let me just talk you through that code. So for D in devices, which is the device list, if the entry that we're looking at is not a software entry, we are not interested in that, and we continue, then we initialize the OS name, the operating system name to nothing, and we reset the number of patches variable. And then we loop through the software installations for the individual device and store the name of the operating system in this variable OS name if it's an OS entry, if the category is operating system, and if the category of the software is patch, we just increment the number of patches. And finally, when we are done with that loop, if that operating system version that's running on the device that we have just examined is not Windows, then we simply continue. So the next step here in our patch list, in our result variable, we have to look up if the number of patches already exists, because in that case, we will simply increment the counter for this number of patches. Remember, we are interested in the patch distribution. We want to see how many devices have just, for example, 100 patches, how many have 200, or any other number. And in order to do that, we have created this structure for our result list where we say, okay, if that number is already known, then we increment the number of patches for that particular patch number. And we also append the device ID to this result list, because at some point in time we may want to know exactly which devices have a given number of patches. And finally, if the patch number is not found in the output result list, then we just create a new entry. So that, and this is going to be the first entry with one device in that particular space. So let's just execute that. And that was pretty simple. Now let's look at our result list. And that doesn't look too shabby. But as we can see, it is not sorted. So it starts, for example, with the first entry. It has 204 patches. There is one device with 204 patches, and we actually want to have that list sorted. In order to do that, we use the item getter function from the operator module. And then we can sort the list, and we write the sorted list back to our patch list. Now let's look at the patch list again, and there we have it. So it starts with 3 patches for one device, which is pretty low. Then we have 10 devices with 6 patches and so on, and our last item here in that list is one system with 413 patches. So far so good, but certainly that's nothing that you could present to your boss or even to your coworkers. What we actually want to see is a graph, or in other words, a histogram, a frequency distribution. And why not just do that in Python by using matplotlib, which we import here. And now here is one funny thing about matplotlib. It actually expects us to enter raw data, and which is funny in our case because we already have the aggregated numbers. So for example, we have these 10 devices with 6 patches, and in order to use that as input for matplotlib, we need to expand that. So we would need to write the number 6 10 times in a row. However, this is not too difficult in Python, so let's just do that rather quickly. First, we define a new result variable, which we call patch counts, and it is again a list. And we are now expanding the results into that list. So for P in patch list, which is our initial result list, we now extend the number of devices into our new result variable patch counts. And this is now something that we can pass to matplotlib, and in particular to the hist function, which will draw us a nice histogram. In order to show that histogram, we have to call plt.show. And there it is. So let me just go back to the code here. What you see is that we have defined a couple of bins. So we don't want to see all the individual patch counts. We have put the various patch numbers into buckets or bins, as it is called for matplotlib. And I think the output is pretty interesting. Unfortunately, is not what we would like to see. So we see here that we have the highest number of systems in the lowest bucket, in the lowest bin, which is less than 100 patches. And then we have a smaller number of devices with more than 100 patches. And so it goes. And ideally, in a perfect world, the distribution would look completely reverse, where you have the highest number of systems with the highest number of patches. But this is real life, where things might not look perfectly. What we are going to do next is that we add the Windows operating system versions to our patch list, to our result list. And as you can see in the array that is still up on top of our program statement, we only see the device numbers and the identities, but we don't see the operating system version. So let's just add this rather quickly. First, we have to reset our patch list to an empty list. And the code that we will be using now is that along with the numbers of patches and the device IDs, we also add the operating system name to our result list. In our new output list, we have now first the number of patches, then the operating system name, then the number of devices with that patch number, and then a list of device IDs. Let's sort this list again and check it out. So there we have now all the operating system versions, the number of devices and the device IDs of those devices. Let's just quickly put that into a diagram. Again, we will have to transform this first into a data structure that matplotlib can digest. And in order to do so, we define a couple of intermediate variables for the various operating system versions, beginning with Windows XP. Then we have Windows 7, then we have Windows 10, and we also have Windows 2K. So these are now our 4 intermediate lists that we are only producing for matplotlib. And we have to extend our results again like we did earlier. Only this time we are doing it for every single operating system in our list. Now we could already draw a diagram for this in matplotlib, but before we do that, we really want to go all the way and also provide a legend, which makes it much nicer and easier to digest. First we set the title, which we simply call patch distribution. Then we set the label for our x-axis, which is number of patches. Y-axis is number of devices. And then we can call the histogram function from matplotlib. And we also tell matplotlib to show us a legend so that we can distinguish the various operating system versions. So let's just plot. And there we go. This is our result diagram. And I don't know about you, but I think this looks rather much more interesting than the first version, because now we can see the operating system versions in our buckets or in our bins. And let's just talk through the results. First of all, in the lowest bucket with less than 100 patches, we see a high number of devices running Windows XP, which probably didn't surprise us that much, but anyhow, there is actually no reason why especially a Windows XP device should be in that lower bucket, because you could argue that especially those devices that you wouldn't want to see on the plan for in the first place these days, they should at least show a reasonable amount of patches. Apparently this is not the case. And what we also see that even for those XP boxes, there are a couple of systems that do have more than 200 patches. So guys, you can do better, I would say to my admins here. Because apparently this is the steep decrease in number of patches or number of devices, excuse me, is obviously not in that amount justified by that totally outdated and obsolete operating system version. The other interesting fact that we see in the lowest bucket with less than 100 patches is that we find a device running Windows 10. So we have a fairly recent operating system version, but completely out of patch. So this is another hint that in this case, the operating system version really is not the most important factor for our patch distribution. And finally, we see a fairly even distribution in respect to the Windows 7 boxes, which will be out of support now in a couple of months. And there we see, well, again, that there are that there is actually the leader of the pack. One system with more than 400 patches is running Windows 7, so you can do pretty well in respect to Windows 7, but apparently this is not true for those other machines in the lower buckets. Now you may wonder, why do I have to use a programming language to produce patch management metrics? Well, you don't. The point I'm making is that OTBase allows you to access and process raw inventory data using third-party custom code. It also means that the third party that you're using or contracting with can be an expert in their fields, and that could be cybersecurity consulting, but it could also be a more engineering type of use cases. And if you are such a service provider, such as a consultant, for you it means that you don't even have to be on site to process your client's data and to provide meaningful results. To learn more about OTBase, please watch the other videos on our channel and also download the free evaluation software from our website.